Hi everyone, welcome. So this is the video of statistical thermodynamics, important formula list. Actually, many students just ignore this chapter, but because of huge competition, I will suggest you don't ignore this chapter. Okay, I agree. Lot of formulas are there, huge number of formulas are there, but still if you focus on important formulas only and if you practice previous year questions, then definitely you can attempt the questions on statistical thermodynamics. Especially if you see compared to GATE, right? So very less number of questions you can expect in CSIR NET exam. But when it comes to GATE, statistical thermodynamics is also very important. If you want to have a very good rank, if you want to be in a top position, then definitely you have to consider this statistical thermodynamics chapter 2, right? So you don't need to worry. I'm going to provide you a very important formula list of statistical thermodynamics. First of all, what you have to do is you have to remember all these formulas, you have to by heart all these formulas, you have to understand all these formulas. After that, I will provide you in the next video or later or in lateral videos, I am going to provide you the application of these all formulas, right? Once if you know how to apply these formulas to the problems and if you do the previous year questions, then definitely you can attempt the questions on statistical thermodynamics in your exams also, right? So if you see, I'm going to provide you some important units along with important units, remaining important formula list also, right? So let us see what are the important things. First of all, you always have to remember important units. So in these important units, first of all, this Planck's constant, always you have to remember h equal to 6.626 into 10 to the power of minus 34 joule second, and Boltzmann's constant 1.38 into 10 to the power of minus 23 joule per Kelvin. If you remember these units only, you can do any question regarding thermodynamics and statistical thermodynamics. Otherwise, it is very difficult to do the questions, right? And C, the velocity of light 3 into 10 to the power of 10 centimeter per second. Na, Avogadro number 6.022 into 10 to the power of 23 per mole, and 1 angstrom equal to 10 power minus 8 centimeters and 10 power minus 10 meters, right? So you have to note down these all important units. Next important formula in statistical thermodynamics, the first and foremost formula is entropy, that is S equal to Kb ln W. You already know Kb is nothing but Boltzmann's constant. Okay, I have given the unit here, and after that, this Kb ln W, here W is nothing but this number of arrangements, right? Number of arrangements. How to calculate the number of arrangements for a molecule? If you don't know, I will explain you in lateral videos, right? Just remember here. And next important formula, S equal to R ln W. R is nothing but gas constant 8.314 joule per Kelvin per mole. R ln W. W is nothing but your number of arrangements again, right? This is very important formula. On this formula, you can expect one question regularly in GATE, right? So next important formula, distinguishable particles. We have two kinds of particles are there, distinguishable and indistinguishable particles, and we have two kind of approaches to that. Means no restriction and restriction. What is this? So no restriction is nothing but, for suppose if I have any energy level here, right? So if examiner mentions specifically that two particles only in this energy level, or specifically only single particle partition function. Single particle partition function means only one particle is there in this energy level. That means specifically if examiner mention anything like this, two particles are there in first energy level, three particles are there in second energy level like this, that is nothing but your restriction. Otherwise, if examiner don't mention anything, that is nothing but no restriction, right? So distinguishable particles, that is different particles with no restriction. So here the formula is W equal to, that is W equal to number of microstates. Here W equal to microstates. M is nothing but your number of levels or number of states you can say, and N is nothing but number of particles. Here the formula is W equal to M power N. Bus. This is the only formula you have to apply when you have this condition distinguishable and no restriction. When you have the condition of distinguishable with a restriction, that means examiner will specifically say anything, okay, then you have to use these A, B, C formulas. We have three formulas here whenever you have this condition. The first condition, W equal to M factorial by M minus N factorial. M is nothing but number of levels, N equal to number of particles. Here examiner will mention if occupation number. right? If any occupation number is there, then W equal to n factorial by pi. Pi is nothing but multiplication symbol, pi n I factorial. Here n factorial is nothing but total number of particles. Okay, here small ni is nothing but particles in ith level. Okay, for suppose if I have the first level, then you have to write n1 here. If you have the second level, n2. Or if you have three levels, n1, n2, n3, then here multiplication sign is there. So n1 into n2 into n3, you have to write here, right? Here n factorial is nothing but total number of particles, right? So you have to use, this is the second formula of this condition. This is the first formula of this condition. This is the second formula of this condition. And third formula is also there of the same condition if degeneracy mentioned. Okay, if examiner mentioned degeneracy, then you have to use this formula n factorial into pi into zi power ni by ni factorial. N equal to number of particles in ith level. Zi means degeneracy of ith level. Okay, here total number of particles. Okay, next condition is indistinguishable particles. Till now we have seen distinguishable particles. Now these are indistinguishable. Indistinguishable means same particles, right? Again, no restriction. If this condition is there in question, then you have to use this formula n plus m minus 1 factorial over n factorial into m minus 1 factorial. You know how to derive the factorial, how to find the factorial. For suppose if I have 3 factorial, then you have to write 3 into 2 into 1, right? I hope you have this basic idea on factorial, right? So if examiner mentioned particularly bosons, for bosons also you have to use this formula only. Okay, if examiner mentioned fermions, for fermions you have to use this formula only. Okay, if examiner mentioned fermions, or in question if you see indistinguishable particles with restriction, then you have to use this formula. If in question if you see indistinguishable particles with no restriction, then you have to use this formula. Okay, this same formula is for bosons and this same formula is for fermions. Okay, here in this condition, indistinguishable restriction condition, we have 2 formulas. One formula is this, and second formula is again if you have any occupation number. Examiner mentioned indistinguishable with restriction with occupation number given, right? Then you have to use pi, means multiplication, zi power ni by ni factorial. Okay, this is the degeneracy of ith level. Here number of particles in ith level. Here you have to take number of particles in ith level. Okay, you have to multiply this whole term, this term into this term. For suppose if I have first level, z1 power n1 by n1 factorial into z2 power n2 by n2 factorial, like that you have to multiply, right? So this is the next formula. Next important things, you have to remember these ensembles. Microcanonical ensemble, examiner will directly ask one question on this, especially in gate. N variable, V variable, E energy variable, constant. Here number of particles, right? Canonical ensemble, number of particles, volume, temperature constant. Grand canonical ensemble, mu, volume, temperature constant. Isobaric, isothermal ensemble, number of particles, pressure and temperature constant. Okay, so these 4 are very, very important. And partition function next. Always you have to remember, partition function is always unitless. For suppose if you want to calculate the partition function, your answer you have to get in unitless only. If you get any unit, that means your answer is wrong, because you are calculating for partition function. Always remember, partition function is unitless. And the partition function formula summation, that means you have to add the terms, summation zi e power minus ei by kt. K is nothing but Boltzmann's constant, T is temperature, E is nothing but energy of ith level. Okay, Z is nothing but degeneracy of ith level. Okay, this is very, very, very important formula, partition function. Next, if this partition function, when temperature is 0, okay, so when temperature is 0, your partition function is Z0. How? So how? I will explain you in lateral videos how this will obtain, right? In lateral videos I will definitely explain you, because questions are there on this. I will explain you clearly. Okay, for now you have to remember like this only, right? At T tends to infinity, if the condition is temperature is tends to infinity, if too much temperature is there, then your partition function equal to summation of Zi. Here partition function equal to Z0 means only ground state is accessible. Here summation of Zi means Z0 plus Z1 plus Z2 plus Z3 and so on Zi. That means all states are accessible. Okay. Next, canonical partition function. Canonical partition function, First one, again two conditions are there in canonical partition function. The first one, distinguishable particles. Here the canonical partition function is indicated by this big Q, right? Capital Q equal to Q power n, small q power n. Here small q is nothing but molecular partition function and n is nothing but number of particles, right? Next, if you have indistinguishable condition, canonical partition function with indistinguishable condition, indistinguishable particles are there, then your q equal to q power n by n factorial. One question already came on this formula in previous year, right? Next, translational partition function. Translational partition function, if you have 1D box, right? In translational partition function, if you have 1D box, then this formula is very, very important. Root over 2 pi m kt over h into Lx, right? So if for 3D box, I have to write root over 2 pi m kt whole power by h into Lx into Ly into Lz. Lx into Ly into Lz is nothing but your volume, right? So combinedly for 3D box, I can write like this because this is 2 pi m kt whole power 1 by 2 over h. I can write like this into Lx. And again 2D box 2 pi m kt whole power again 1 by 2 over h into Ly. 3D box 2 pi m kt whole power 1 by 2 over h into Lz. If you multiply these three terms, you will get this one for 3D box, right? So Lx into Ly into Lz, that is nothing but volume, right? Directly remember this formula. This formula is very, very important. This formula is not that important, right? So 2 pi m kt over h cube. Here 2 pi m kt whole power 3 by 2 over h cube into volume. Okay, this is the translational partition function formula. In some questions, okay, you have to convert this formula like this. How? See, 2 pi m kt over h square whole power 3 by 2 into volume. I can write like this. How? Because here 2 pi m kt whole power 3 by 2. Okay. Here h square whole power 3 by 2, that means h power 6 by 2. 2 cube, that means h cube I will get again. So I can write this formula as this also, right? Next formula of translational partition function. Importantly, first of all, mainly two formulas are there for translational partition function. The first formula is this, second formula is this. Okay, you have to remember these two formulas mainly. So next formula, V, that is volume by lambda cube. Your lambda is nothing but thermal wavelength, that is lambda equal to h by root over 2 pi m kBt. Boltzmann's constant, temperature, here mass is nothing but kg. Mass should be in kg. You have to remember, if examiner will give you the mass in kilogram, it is okay. Otherwise, you have to convert first into kilogram, then you have to put that value here. Okay, this formula is very, very important. Questions can expect in GATE on this formula. Okay, next, rotational partition function. If I take rotational partition function, see, again you have two conditions for rotational partition function. The first condition, if your temperature, normal temperature is less than rotational temperature, theta r is nothing but your rotational temperature, then rotational partition function is summation of zi e power minus ei by kt. Here degeneracy equal to 2j plus 1. You have to use this formula to calculate degeneracy, and you have to use bj into j plus 1 to calculate this energy, because this is the rotational partition function. Okay, you already seen your rotational spectroscopy in physical chemistry. Okay, you in energy of the rotational partition function or rotational spectroscopy, in rotational spectroscopy residual term bj into j plus 1. You have to use that formula here, right? So next important one, this is the first condition, T less than theta r. Second condition, if temperature is greater than rotational temperature, then your partition function, rotational partition function is kBt by B. Okay, this B is nothing but rotational constant. So kBt by B rotational constant value, h square by 8 pi square I. Okay, you know this. So if I put B value here, then I will get this one. Okay, this formula also very, very, very important, right? Next, rotational temperature. The rotational temperature indicated by theta r equal to B rotational constant over K, right? Boltzmann's constant. If I put B value here, h square by 8 pi square I, then I will get this formula, right? So if you observe here, I is nothing but your mu r square, because here moment of inertia I equal to mu r square. So finally I can write this one from this equation, from this formula, I can have the relation. This rotational temperature is inversely proportional to the mass, reduced mass. If mass will increase, rotational temperature will decrease. If mass will decrease, rotational temperature will increase. Right? Again, next condition, theta r is inversely proportional to the I, moment of inertia. If moment of inertia increase, rotational temperature decrease. Okay. Next important thing you have to remember here, rotational partition function is this, right? Here, what is the sigma value? Sigma value is nothing but symmetry number or indistinguishability factor. How you have to calculate this sigma? If you don't know, I will explain you in later videos. Right? Next, last one is vibrational partition function. Again, you have two conditions here. One is without 0 point energy. One is with 0 point energy. Especially this with 0 point energy is very, very important if you compare with without 0 point energy. Right? Examiner generally asks questions on this. Right? Your vibrational partition function equal to 1 over 1 minus e power minus hu by kbt. This is one formula. And next one, vibrational partition function equal to e power minus hu by 2 kbt over kb or k, both are same. Don't confuse. Right? Boltzmann constant only. Over 1 minus e power minus hu by kt. Right? This is very, very important. Next, vibrational temperature. Vibrational temperature theta v, it is indicated by theta v equal to h nu over k. Right? From this formula, you can write theta v is proportional to nu. You know, from vibrational spectroscopy, nu equal to 1 by 2 pi root over k by mu. Right? So from this, I can write theta v is proportional to nu. If I put nu value as 1 by 2 pi root over k by mu, then theta v is inversely proportional to the mu. That means, if mass will increase, vibrational temperature will decrease here. If mass decrease, vibrational temperature increase here. Okay, so like this only. If you see, rotational temperature is also inversely proportional to the mu, and vibrational temperature is also inversely proportional to the mu. Right? Next, this is also very, very important. If you have this term 1 by kt, you will get this term in solving the questions. So if you get this term, okay, sometimes you have to write like beta. Okay, 1 by kt, which is equal to beta. Right? Next, vibrational partition function under high temperature. If you have the high temperature, then the formula is vibrational partition function qv equal to T normal temperature over vibrational temperature theta v. Okay. Next important formula, very, very important formula for CSIR NET and GATE. Already in previous years question asked on this in CSIR NET also. Right. This is internal energy U equal to nkt square dou ln q by dou t at constant v. Here q is nothing but your partition function. Right? Questions are there on this. Previous questions are there. For suppose I can write this total number of particles n as n into Avogadro number. Okay, number of particles in ith level into Avogadro number, and this Boltzmann constant equal to gas constant by Avogadro number. Okay, if you take the gas constant value and if you take the Avogadro number and if you divide this, you will get this Boltzmann constant. So n and a into, in place of Boltzmann constant, I can write r over Na into remaining thing t square into dou ln k by dou t, dou ln q by dou t at constant v. Right? If I write this equation like this, then what happens? This Na will get cancelled. Then nRT square dou ln q by dou t at constant v. Again, you will get this formula. Right? You have to remember these two formulas. These two formulas are important to calculate internal energy. Next, Stirling approximation to derive to find out the actually this Stirling approximation is useful in calculations. Okay, so this is not a formula. Actually, this is useful in calculations. For suppose in place of n factorial, if I have ln 100 factorial, right? So then you have to use this. How you can use 100 ln 100 minus 100. Okay, if you have this value ln 100 factorial, then you have to use like this. Okay, this is important, Stirling's approximation. Next important thing, Helmholtz energy A equal to minus kT ln q. This formula is also important, and this you already know. This is canonical partition function q equal to q power n over n factorial. right? So these are the important formulas, and also some important formulas are there. Okay, so this is also important formula. This is translational entropy. Okay, one question is there, one previous year question is there on this. This translational entropy is proportional to ln m power 3 by 2. I can write this 3 by 2 ln m. That means mass is directly proportional to the translational entropy. If mass increase, translational entropy will also increase. Okay, next important formula, this n equal to summation of ni. If I have total number of particles, in place of n, in problems, sometimes I can write n equal to summation of ni, right? This summation of ni, which is equal to summation of zi e power minus ei by kt, right? This is partition function. And this ei by kt, this e power minus ei by kt is nothing but your ni. If I have n1, then I can write e power minus e1 by kt. If I have n2, e power minus e2 by kt, you have to write like this. Okay, this formula is also very, very important. There is no other alternation. You have to remember these all formulas. You can by heart these all formulas, then only you can do the questions, right? Very easy. Just revise every day for 1 week. Definitely you can remember these all things, right? Next important formula is partition function, and probability is given. If probability is given, then partition function q equal to 1 by p naught. Okay, this partition function is inversely proportional to this probability. Last important formula is this very, very important formula, that is fraction of particles or probability. If you want to find out the probability, or if you want to find out the fraction of particles, then you have to use this formula. For suppose if 2 states given by the examiner, then you have to use probability to find out the probability equal to ni by n, number of particles in ith level by total number of particles. In total number of particles, you can write this formula, summation of ni, right? Summation of ni. So this ni over summation of ni is nothing but n0 plus n1 plus n2 and so on ni. That means if 2 states is given, n0 and n1, I can write like this, ni over n0 plus n1, right? So this is also important one. Okay, these are the important formulas. Okay, just remember these formulas, by heart these formulas. Next application video will come, then you will get a very clear idea that how to apply these formulas to the questions, right? So that's all for this video. Thank you so much for watching.